Hi everybody. Let's practice with this isosceles triangle theorem and the triangle sum theorem both at once. Make some decisions. Consider the isosceles triangle ABC with base BC. Ask me right away which angles would be congruent. And you might know immediately, but I'm going to make a sketch of an isosceles triangle with ABC with base BC. If BC is the base, then AB and AC are the legs. So which angles are congruent? Yeah, it'd be angle B and angle C, wouldn't it? Which is awful helpful because it tells me about angle B and angle C. You say, well, base angle's got to be congruent. So right off the bat, I can find the value of x this way. If I make a little note that angle B is congruent with angle C, can't be a bad thing to think. And then comes along with 6x minus 2 must be the same as 4x plus 12. Let's solve that little equation. I've got to subtract 4x from both sides, which is just leave me with 2x minus 2 is equal to 12. Bring that 2 to the other side, and I got 2x is equal to 14. So now I'm convinced that x is equal to 7. I'm supposed to find the measure of each angle in this triangle, so I can do that pretty quick. Measure angle B. If x is really 7, 6 times 7, 42, minus 2 would be 40. And the measure of angle C should be the same, but 4 times 7 is 28 plus 12 would also be 40. What about the measure of angle A? Well, the angle should add up to 180, and there's 80, so I guess angle A is 100. My picture is not nearly drawn to scale, but it did clue me to which angles had to be congruent. Same kind of thing right here, but a little bit different. Triangle PQR is isosceles with base PR. I'll just go ahead and make a sketch. Base PR and my triangle PQR. If PR is the base, then PQ and RQ are the legs, and angle P would have to be congruent to angle R. Once we talk about that, I can tell them angle P is congruent to angle R. But it tells me about angle P and angle Q. But what we should do is rely on the triangle sum theorem that the angles of this triangle got to add up to 180. Angle P is 9x minus 1. Angle R's got to be the same amount, also 9x minus 1. Well, angle Q was 2x plus 2. So it seemed like we could add up those three angles of this triangle and figure the value of x, set them equal to 180. So I'll jump right in with 2 times 9x minus 1, because I got a couple of those base angles, plus that vertex angle of 2x plus 2 ought to add up to 180 degrees. Multiplying through those parentheses, I got 18x minus 2 plus 2x plus 2 equals 180. That gives me 20x, doesn't it? And the negative 2 and a positive 2 fall off. So I have 20x equals 180. Divide both sides by 20, and we figured that x is equal to 9. We'll go ahead and find the measures of those angles. Measure angle P. Yeah, I can do that. 9 times 9 is 81, minus 1 would be 80 degrees. And what about the measure of angle R? Has got to be the same, doesn't it? Measure angle R, because it's the base angles of an isosceles triangle, also 80. Now if this is 80 and this is 80, this one better be 20, because I got 160 and 20 give me 180. But let me check that. Measure of angle Q. If x is truly 9, 2 times 9 is 18, plus 2 be 20. So I'm comfortable with those. These are the angles of that triangle. Let's play some more. Check out these two isosceles triangles. It tells me that AB is congruent to BC. I need to mark those right away. And that CD is equal to CE, is congruent with CE. So here I've got an isosceles triangle, and there I do as well. And it goes on to tell me that the measure of angle A is 32. Let me make a little note there some kind of way. That's a 32 degree angle. Let's see if I can't find out about these numbered angles. The first one that comes to my mind is the base angles of this isosceles triangle got to be congruent. So angle 2 would have to have been 32. And 32 here and 32 there is giving me 64. Subtract 64 from 180, we'll know angle 1. I think it'd be 116, wouldn't it? So I think I'm done with that triangle, pretty much, except it gives me about this angle, doesn't it? If we knew that angle 2 was 32, wouldn't the vertex angle of this isosceles triangle also have been 32, knowing that vertical angles are congruent? So what about angle 3 and angle 4? Well, they are the base angles of this isosceles triangle. They ought to be congruent. And if 32 went there, I've got to subtract that 32 out of 180. That'd leave me 148 for those to share. I think that'd be 74 apiece, huh? 74 and 74 is 148, plus that 32 gives me 180 in that triangle, so I'm comfortable with that. Let's play some more. A little mustard on my paper, sorry about that. In this figure, consider ABE to be equilateral. I'll mark it that way. EDB is a scalene right triangle, got a right angle right there, and the sides aren't congruent. I don't know that that's isosceles. It's not isosceles. And triangle DBC is isosceles with base BC. So I should mark that this segment is congruent to that one. And jump in and go start finding those numbered angles in this triangle. Now, you seem like we might want to pay attention to that triangle, but I think we better start here first. Wouldn't this angle have to have been 60? Gotta be. And now, how can I move out of that triangle and get some more things going? Oh, here, I did overlook this. Angle EBD is 40. EBD. This angle's got to be 40. And if this one's 60 and that one's 40, there's 100 right there. And this is a linear group, not a linear pair, because there's 3 of them, but I can find this angle. There's 100. Wouldn't angle 1 have to be 80? That way they'd add up to 180, so I got angle 1. He said proudly. Angle 2 is going to be the same, because they're base angles of that isosceles triangle, also 80. And what about angle 3? Well, this one's 80 and this one's 80. That's 160. How much is left for angle 3? Yeah, I got to agree with you. That's going to be 20 degrees, isn't it? And then it looks like we got a proof to do. A pretty nice proof, too. Given that this is an isosceles triangle, and AD is an angle bisector, isosceles triangle, and this is an angle bisector, we're supposed to prove that it's perpendicular to that base. I've got it set up to do that already. You might want to make a sketch like this one before we do that. I'm ready to jump in and start doing it. People say, I don't like proofs. I don't know how to get started. Well, I'll tell them, investigate that given. So what that triangle's isosceles with base BC? Well, that has consequences. That would be that AB is congruent with the other leg AC. Just because it's isosceles, you think two sides are congruent. And I say, yes, I do. That's the definition of an isosceles triangle. And then let me mark them that away. And AD bisects angle BAC. Now, if this is an angle bisector, we got to talk about these angles up there, huh? We call them angle 1 and angle 2. And I hope you can agree with me right away that those angles got to be congruent. If AB is an angle bisector, it divides this angle into 2 congruent parts. Angle 1 congruent with angle 2. Why do you think so, mister? Well, that's what angle bisectors do. Don't want to write. That's what angle bisectors do. I'll say definition angle bisector. And then mark them that away. Now I could use the isosceles triangle theorem here. Why not? I think I will, just because I think it's kind of clever. Isn't it true that angle B would be congruent to angle C? You could use the reflexive property. That would have been fine, but I'm going to go a different route. I'm going to say angle B is necessarily congruent with angle C. My reasoning is that's the isosceles triangle theorem. When two sides of a triangle are congruent, then the angles opposite them would be congruent. So this angle would have to be congruent to that one. Let me mark them that way. And I think I got congruent triangles here I can talk about. Let's make a statement about them. Triangle. If I call my first one BAD, triangle bad, got to be congruent with that other fella. Now if I went BAD, you go CAD, huh? CAD. How'd you get those triangles to be congruent anyway, mister? Well, I got an angle, a side, and an angle congruent to an angle, a side, and an angle. I guess I'll call that angle side angle. But then we come to this pretty interesting thing that a few people have figured out how to do. How do we establish perpendicularity? How do I know to say that AD is perpendicular to BC? I got to talk about these angles 3 and 4. The real ticket will be to show that they are congruent and supplementary. If they're congruent, then they're equal in measure, and if they add up to 180 and they're equal in measure, they're going to have to be a 90 apiece. That's a theorem that we've proven before, but let's see if we can employ it now. First, I would say angle 3 is congruent with angle 4. Just because these triangles are congruent, I think that those angles would have to be. You say, I think so too, because corresponding parts of congruent triangles are congruent. Would you agree that these are supplementary, angle 3 and angle 4? I think so. Angle 3 and angle 4 are supplementary. What makes you so sure they're supplementary anyway? Well, they make a straight line together. So I'm going to use this old axiom. If it's a linear pair, then they got to be supplementary. I think that would fit pretty well. Now I've got these two angles that are congruent and supplementary, and if they're equal in measure and they add up to 180, I can conclude that those angles are right angles. I'm going to say angle 3 and angle 4 are right angles. I got to write a little sentence over here. Two angles, congruent and supplementary, implies right angles. So I know that 3 and 4 are right angles. Now, if these are right angles here and there, does that force AD to be perpendicular to BC? I mean, after all, what do you got to do to be perpendicular? Lines are perpendicular if and only if they form right angles. These form right angles, so by golly, they're perpendicular. So I can finish this on my 9th step. I would conclude that AD is, in fact, perpendicular to BC. Just because it forms right angles, you'd think it's perpendicular. I say, yes, I do. That's what it means to be perpendicular. That's the definition of perpendicularity. Lines are perpendicular if and only if they form right angles. So I say that's done. And I appreciate you walking through there with me.